So the second important limit right here is actually the cosine one. Okay, so the second limit, I write it right here. I don't know why it's not on our lecture, but this is the second important limit. As limit x approaches 0, cosine x minus 1 over x is equals to 0. So it's basically right here. This is just an example right here. Okay. So if we utilize the limits like this is how we can prove it. To prove it, we have to just multiply cosine x plus 1 on both sides. We get that, and then we can use some easy derivatives right here and finally get that it's equal to 0. So that is the second important limit. So this is number 2, and memorize this, okay? So next I want to talk about the E. Okay, so what is the E here? Okay, so the E is actually it's basically like, for example, log E, right, equals to 1, right? Because E is the logarithm of the function here. Okay, so I will talk about E here. Okay, so in limits is represented by limit of x as it approaches infinity. So because it approaches infinity, of e of 1 plus 1 over x to the x squared. This is always equal to e. You can memorize this. It's not really used a lot, but it's really important in your future life, okay? Same as here. If it approaches 0, we just have 1 plus x to the 1 over x equals to e, okay? So this is also crucial. So the value of e is actually 2.718 is the golden ratio, we call that, okay? This is all just knowledge you might want to know, okay? So we're gonna move on right here. So this is the limits involving infinity. Many people want to learn about this. So this is called the horizontal asymptotes. And as I talked about in a few classes before, I briefly mentioned what the horizontal asymptote is. It's basically like that. This is a asymptote. It gets extremely close to the asymptote. So for example, this is y equals to 2. Let's just say. So this it approaches to, so here the limit actually approaches to right here. So this is called an asymptote. So the asymptote for this, when something approaches something, it's just a constant. The asymptote for this would be 2, as I drew here. Okay, so here you just need to take a look at that and then take a picture. This is a key. Memorize that, and then we'll talk about an example right here. So the example is actually find limit of as x approaches infinity of the function 2x squared minus 1 over x squared plus 3. Okay, so obviously if we just cut that limit in right here, infinity, it will just be, okay, it will just be